let's talk about NFAs and DFAs. We were talking at the very end last time about regular languages in general. Remember, a regular language is the language of a DFA, but we also have NFAs which have more capabilities. So NFAs can do more than DFAs. I mean, in terms of like what is allowed on an NFA diagram, NFAs can do more than DFAs. More, I mean specifically they can have epsilon transitions, and they can also have several or no arrows, right? Remember, a DFA must have one arrow per letter going out of each state, but an NFA can have more than one if you want, and it can even have 0 arrows per letter if you want. All right, so an NFA diagram, if anything, it can be more sophisticated, or it can do some stuff that DFA diagrams cannot. But the question I was trying to raise last time was, can you actually get different kinds of languages from an NFA than you can from a DFA? So NFAs can do more than DFAs, but can NFA generate any language that a DFA cannot? This is an interesting question. Because the NFA is allowed to do certain things, I think the natural answer is, well, yeah, probably the NFAs can create languages that DFAs can't. But the alternative would be maybe actually they have the same capabilities, and in that case it means that these extra gadgets that the NFA can do, the epsilon transitions or whatever, maybe those things allow the diagram to look different, but they end up creating the same languages anyway, just by some kind of a coincidence. For example, here's an example of NFA DFA, like the language, let's say A to the N, B to the M. We had an NFA for that last time that used some epsilon transitions. So this is actually a fairly easy language to do using an NFA like this. I don't know if you remember last time, but this is an example we had last time. This accepts anything which has a bunch of A's followed by a bunch of B's, where it's some other number of B's. They might be the same number, they might not. All right. And how do you see those are accepted? Well, if you want to do just some A's, you start here, you go up through the epsilon without reading any letters, and then you do a bunch of A's. You could stop then and it would be accepted. That would be if you did no B's. Or if you want, you can do this epsilon here and then do a bunch of B's. So this allows a bunch of A's followed by a bunch of B's, but then you can't do anything else after that. You can't do more A's after the B's. All right, that's an NFA. Can you do this with a DFA? The answer is yes, although it has to be a little bit more complicated. You need more states. So this is an NFA for that language. We can also do a DFA. I worked this out ahead of time. This is harder, in my opinion, to work out the details of. But this is a DFA, which does the same thing. I'm not allowed to use epsilons in this case. So what I have here is you can, first of all, when you start, the empty string should be accepted in this language, because that would be the case where N and M are both 0. So in a DFA, the starting state must be accepting. In NFA, it's not necessary because you can just do epsilon here and be accepted with the empty string. But anyway, so the empty string is accepted. Now, if I do an A first, I could continue to do more A's and then do some B's, and then it would be accepted, right? Or I could not do any A's first, do a B first, and then do some more B's, and it would be accepted. But if you ever see an A after this B, then it will be permanently rejected. So this is a DFA for the same language, all right? This is a DFA. Can you see any relationship between those two diagrams? The answer is basically no. I mean, they look quite different, and there is not. I mean, I'm not seeing anything where you can just tell at a glance that they generate the same language. They do generate the same language, but it's not, in my opinion, not easy to tell at a glance. But I'm here to tell you what we're going to do today is there is actually a fairly straightforward procedure. It'll take you a few minutes to work it out, but there is a procedure to convert this diagram into this one. There is a general purpose procedure which will take an NFA diagram and convert it into an equivalent DFA diagram over here. And in fact, if you do that procedure, which we're going to learn how to do today, if you do it to this, you will get this, all right? So there is a procedure, there is a construction to convert any NFA to an equivalent DFA. All right. And we're going to talk about how to do that today. It has a name, a cute name. It's called the subset construction. And it's vaguely like the product construction, which is what we were doing last week and what you're doing on the homework, where you can take two different DFAs and combine them together by making pairs of the states. That's called the product construction, and you can use that to make a machine for the union or the intersection of two original DFAs. This is called the subset construction, but it is a general purpose method for converting any NFA into any DFA. Just the fact that this exists at all, or that this is possible, one thing that automatically means is that any language you can do on NFA, you can also do that same language on a DFA, because you can just convert the NFA into a DFA. So this question up here, can NFA generate any language that a DFA cannot? The answer is actually no. Because every NFA can be converted into a DFA. That means the language that the NFA makes is possible to do that same language with a DFA. So I'm going to put a big old no here. That's a bit unfortunate, perhaps. I don't know. It means that NFAs they are sort of more convenient sometimes than DFAs. Like in this example, the NFA is a lot simpler than this one over here. But the NFAs do not actually have more computational power in the sense that they cannot create new languages that DFAs can't. They create the same set of languages, and they are the regular languages. All right, anyway, let's talk about this subset construction here. I'll tell you how to do it. Do a couple examples. I got one for you to try also if we get that far. So I am going to start, remember the idea is you start with the NFA and you create this DFA. I'm going to start with this NFA over here, but you want to give the states names. So I'm going to call them, you could call them whatever you want. I decided to call them Q0, Q1, and Q2. Or you could call them ABC or XYZ, whatever, STU. And so I'm writing that same NFA from before. Like so. This guy are accepting. All right, this is my original NFA. Okay, and it's called the subset construction. That's because our DFA states will be subsets of states from the NFA. All right. Our DFA states will be subsets of states or sets of states from the NFA. As with the product construction, some of these sets will be unreachable from the starting state, so you don't necessarily need to write down all of the subsets. In this case, there are 3 original states. There's going to be 8 total sets of states that you could make by combining those states in different ways, but it's not necessary to write them all down. So I should tell us, where do we start? You basically, just like when you're doing the product construction, you start in the starting state and then you draw the arrows and see where they lead you to. So we start our starting state in the subset machine is I mean, it's basically the same as this one, but you also have to include, so you include the original starting state plus any other states which are reachable from this state by epsilons. So our starting state in the subset machine is the NFA start state plus any other states reachable by epsilons from the start. All right, so in this example, my starting state in the subset machine will include Q0, but also Q1 because Q1 is reachable from Q0 by doing epsilons, and also Q2 because Q2 is reachable from Q0 by doing epsilons. So in this particular example, I'm going to copy this guy down here just so that I don't have to keep scrolling. In our example here, so that's the original NFA here. We are going to create a DFA, and the starting state is this set. Q0, Q1, Q2 is my starting state, all right? The starting state in the subset machine consists of the original NFA starting state, which is Q0, together with any other state reachable by epsilons from Q0. That is Q1 and Q2. All right? That's the starting state of my new machine that I'm building here. Okay, now I got to draw some arrows. I draw an arrow with an A and an arrow with a B. And how do we draw each arrow? Maybe I'll explain that down here. For each arrow, find all states reachable from any state in the set by reading your letter. And I will say parenthetically, this is important, plus epsilons, all right? So what it means is I'm going to try to draw the A arrow from this state. What I want to list out is all of the states which are reachable from one of these. So starting in any of these three, Q0, Q1, or Q2, where could I possibly end up if I read an A and possibly also read epsilons? So for example, if I'm in any one of these three states and I read an A, is it possible to end in Q0? If I'm in any of these three and I read an A and possibly do some epsilons maybe, could I end up in Q0? I think the answer is no. You can't arrive here after reading A, right? Even if you allow some, A followed by epsilon or whatever, it's not possible to end up in Q0. What about Q1? Starting from any of these states, can I end up in Q1 after reading A? I think the answer is yes, because I could start in Q1 and see A and end up in Q1. And what about Q2? Could I end up in Q2 from any of these states after reading A, possibly followed by epsilons? The answer is yes, because you can, if I start in Q1, I can do A followed by epsilon and end up in Q2. All right, so this, you have to think fairly carefully about this. But from this state, if I read an A, I could end up in Q1 or Q2, but not Q0. And so that's where that arrow goes. All right. If I'm in any one of these three states and I read A, possibly also doing epsilons, I can end up in Q1 or Q2, but I can't end up in Q0. All right? That was the A arrow right here. What about the B arrow from here? Same question you have to ask yourself. In any of these states here, if I read a B, perhaps also doing epsilons, where could I possibly end up? Can you end up in Q0? Somebody give me the thumbs. Can you end up in Q0 after reading a B? The thumb is down. You cannot end up here after reading a B, right? Even if you do epsilons after the B or something like that. What about Q1? Can you end up here after reading a B? The answer is, I think the answer is no. You cannot starting from any one of these states, read a B and end up in Q1. You might think, could I start here, do B, and then go epsilon, epsilon? No, because I just went backwards on one of the arrows. There's no way to start here, read a B, and then end up back up there. All right. So could you, from any one of these three states, reading a B, end up in Q2? Yes, you can. If you're in Q2, you can do a B and end up in Q2. So in conclusion, from any of these three states, where can you end up after reading B? The answer is only Q2. All right. So this one, the arrow must go like this to Q2, like that. All right. If I'm in any of those three states and I read a B, the only place you could possibly end up is in Q2. All right. And I'm just going to keep on drawing arrows in this new diagram until we have exhausted all the arrows, right? I'm trying to make a DFA over here, remember? So every state needs two outgoing arrows, a A and a B. Let's talk about the Q1, Q2 state. This might be a little easier to think through. From either of these two states, that means if you're starting in either of these two, and let's say read A, where could you end up? You got to ask yourself, can I end up in Q0? No. Starting from either one of these, reading A, you cannot end up in Q0. What about Q1? I think the answer is yes, you can. You can start here and do A. And what about Q2? Can you end up in Q2? By starting in either of these two states and reading an A, possibly also doing epsilons? The answer is yes, you can. You have to remember to consider the epsilons. You can end up in Q2. From Q1, I can read A and then do epsilon down to Q2. And so, what's the answer? From either of these two states, where can you end up after doing A? You cannot end up here, but you can end up either of those. It is Q1 and Q2 again. That means it's like that. Starting from either Q1 or Q2 and reading an A, you can get back to Q1. You can also get back to Q2. You cannot get to Q0. All right? It's a little tricky. Harder, in my opinion, than the product constructions we were doing last time, because you really have to consider a lot of details. What about from Q1 and Q2? What about when you read a B? Where could you end up from Q1 or Q2 by reading a B? You should just think briefly in your head. Could I, starting in one of these two, reading a B, can I end up here? Can I end up here? Can I end up here? Anybody think you know? What do you say? Yeah? Q2. Just Q2 is the answer. Yeah. If you start in either of these two and you read B, the only place you can end up is here, right? You cannot end up back here. That would require going against the arrows. And you also can't read a B and finish here. All right. So just Q2, that means like so. All right. So we have drawn all the arrows from this one here, right? The Q1, Q2. It's now a matter of drawing the arrows from Q2, right? So I think it through again. From Q2, if I read A, where can you end up? Just in this state now. This is a little easier probably. Where can you end up after reading A? People are just shaking their heads. The answer is you can't go anywhere after reading A. Now, I mean, I have to draw something here. Remember, the states here are represented by sets. So actually, it is allowable to make a state represented by the empty set, and that's what we have to do in this case. So this is the empty set state, and A like that. That means if I'm in state Q2 and read A, you can't go anywhere with that. So there are no states you can end up in, which means I go to the empty set. And what about a B from Q2? If I read a B, where can we end up? Yeah? Yeah, just in Q2, right? You cannot end up in Q0 or Q1 from here because there's no way to get back to those two states. Reading a B, Q2 goes back to itself like so. All right? Okay. So the state Q2 is handled, right? I have an outgoing A and outgoing B. We need to talk about this. This is an easy sort of stupid case, but it needs to be addressed in my diagram here. What about the A arrow here? That means if I start in no state at all, where can I end up after reading A? The answer is you're not going to end up anywhere if you're not starting from anywhere. So this actually is always the case. From the empty set state in one of these subset machines, it always has loopback arrows with every letter on it. So the meaning of that is there are no states that you can reach if you start nowhere and read a A. You can't go anywhere. And also, if you start nowhere and read a B, you end up nowhere. All right? This is the diagram. That's how you draw the arrows. This is, like I said, a little tricky. You have to get used to looking carefully at where the arrows are going to go. We should just say, what are the accepting states in the subset machine? It turns out to make this work properly, the accepting states are any sets containing original NFA accepting states. So in this example, what that means is Q1 and Q2 we're accepting. Sorry to scroll away from what I just wrote. Try and fit it all on there. The accepting states are any states containing original NFA accepting states. In our example here, the original accepting states were Q1 and Q2. So you look over here, and anything over here which contains Q1s and Q2s becomes accepting. That is actually all of them except the empty set state. So this original one is accepting because it contains Q1 and also Q2. This one is accepting, and this one is accepting. Anything which has a Q1 or a Q2 in it becomes an accepting state. All right. And that's how we do it. This is called the subset construction. We started with an NFA over there. We end up with a DFA over here. And the idea is that the DFA is supposed to have the same language as the NFA. I mean, that's not immediately obvious, but we'll talk about that more. All right. I would like to point out this example right here. What you see here, the structure, if you look at it, what we have is sort of 3 states in a triangle and then 1 extra failure state hanging off of that. That actually is the same as this, what I wrote at the beginning. So remember, I told you, I mean, hope you believe me now. There is a construction to convert any NFA into an equivalent DFA. We started with this one. We ended up with this one. All right. The states don't have those weird names to them, but that doesn't matter. It's the same diagram. And if you look carefully, you'll see the arrows are the same as these arrows down here. All right. The subset construction is pretty great. Let's do one more example together, and then I got one for you all to try. So here is the idea is you always start with an NFA and you convert it into an equivalent DFA. Are there any questions about that first? I should say, before we just do another one. All right, let's just do another one. This is how you really learn it, is, to do examples. As usual in mathematics. All right, this is my NFA. This is actually another example that I think I mentioned this example last time. This accepts when, can anybody say what kinds of strings are accepted by this NFA? This actually is not relevant to doing the subset construction, but what kinds of strings are accepted here? Yeah.
An A has to be in the middle.
An A in the middle. Yeah, kind of. I'm not sure exactly what middle means, just because you might have, say, 4 letters or something. Yeah?
The second to last letter needs to be an A.
Yeah, I would say more specifically, the second to last letter needs an A. So you can say it does a bunch of stuff here. I don't care. But eventually it has A followed by 1 more letter. So I would say this accepts when the second to last letter is a A. All right? This one here is only 1 letter. So what we see here is A followed by 1 more letter, and then it's accepted. Okay, anyway, let's convert this to a DFA. This would be a typical, you should probably expect a question like this on our first test, whenever that is. Next week? 2 weeks from now? I don't remember. But yeah, let's do the subset construction. Now, this one actually is quite a bit easier because there are no epsilons here. So like what is often the most confusing is just making sure you are accounting for all of the epsilons. So this one is a little easier than the one we just did. What is the starting state? Remember, the starting state in the DFA is the set of all states, including the original starting state, plus any other things that you can reach by epsilons from the starting state. In this case, there are no epsilons, so all it is just S as my starting state. All right? It's the set of S, but remember the rule is it's the set of the original starting state plus any other states reachable by epsilons from the original starting state, which in this case is nothing. So it's just S. All right, my arrows. What about the A arrow? Where does the A arrow go? You have to think, if I am in S and I do A, where could I possibly end up? Anybody want to say? S and T, she said. Yeah, I agree. If you're in state S and you do A, you could do it here and end up in S again, or you could do it here and end up in T. So this one, the A arrow, goes to S and T. Excellent. What about the B arrow from S? What do you say? Yeah?
S.
Yeah, just S, right. If you are in state S and you do the B arrow from here, the only place you can end up is back in S again. So that is one of these, right? Starting in state S, do B, you end up in S again. Okay, so the S state is handled. What about S, comma, T? If I do A from there, so now I have to imagine I'm in either of these two and I do A. Where could I end up? You should just think briefly to yourself. From either of these two, can I end up back in S? Can I end up at T? And can I end up at U? What do you think? Anybody want to say? Maybe you can end up in any of them, or none of them, or some of them. What do you think?
Could be all of them.
I think it could be all of them. You could, from either S or T, I could start in S and do A and end up back at S. I could start at S and do A and end up at T. Or I could start at T and do A and I end up in U. So you can, there is a way to end up in any of those three by doing A. So I'm going to put that one over here. I already drew this ahead of time so that I would be able to draw this without crossing the arrows. All right. S, if you start in either S or T, you can end up in either S, T, or U. What about with a B? From S and T, where can I end up? Well, I could start in the S and do B, end up at S again. I could start at the T and do B and end up at U. So I can end up in S or U. But I don't think you can end up in T after doing a B, starting from S or T. You can't. So it's just S and U that are reachable from S and T by doing a B. So I'm going to put that one down here, S and U, like that. All right, we got to keep going. Fill in all the arrows. So let's look at the STU state. From here, what about an A? That you look here, starting in any of these three and doing an A, where could you end up? Could you end up in S? I think you could by doing A like this. You can end up back in S. Could you end up in T? I think you could by starting in S and doing an A, and you can end up in T. Could you end up in U? I think you can. If you start in T and do an A, you can end up in U. So actually, STU can go to any of those states by reading an A. So it's one of those. Anything in STU can be reached by reading an A from any of those states in S, T, and U. What about a B? If I start in STU and I see a B, I think in that case I can reach S like this, I can reach U like this, but you cannot reach T by reading a B. So it's just S and U, which means it's like that. All right, and finally, hopefully finally, I don't know, we have to make 2 arrows from S and U. Hopefully we won't generate any new states and then we'll be done. What about the A arrow from S and U? Could I hear from someone else maybe I haven't heard from? What if you are in states S or U and you read an A, where could you possibly end up? Yeah?
S or T.
S or T. Yeah, I agree. If you're in S or U and you read an A, you could go S back to S or you could go S to T. You cannot end up in U if you start from S or U and read an A. And so that would go up there like that. And S and U reading a B, where can you end up? Yeah?
Just back in S?
You can end up, yeah, I agree, just back in S, right? You could go S with a B back to S. You cannot end up in T after reading a B, and you cannot end up in U after reading a B if you started in either S or U. So just back to S, she said. That's like that. And now we're done with the states. I filled in all the arrows. We did not generate any more new states. All right, and then last thing is the accepting states. Remember, the accepting states are any sets which contain one of the original accepting states. So the original accepting state was U. So down here, anything which includes a U is accepting. So that would be the STU and the SU. There you go. This is the diagram for the DFA. And apparently this accepts when the second to last letter is A. Although it's harder to tell by looking at the diagram, but I think we did it right. All right. Any questions about that? All right, I got one for you all to try. You try. I write the NFA, you convert to a DFA. I'm gonna do Q1, Q2, Q3, etc. in this one. All right, 5 states in the original diagram. Although, if you do it correctly, you're not going to get a giant answer. Unfortunately, when you're doing these, if you screw it up towards the beginning, you will really be screwed forever. I don't know what to tell you. Don't screw it up at the beginning. You have to just be careful. Make sure you are taking into account the epsilons. I will just give you a hint just to make sure you're not screwing it up. In the DFA has only 3 reachable states. So if you find yourself generating more and more states every time, you're doing it wrong. Although that's just because I'm telling you, there actually isn't a cute way to know by looking at the NFA diagram. You can't really tell how many reachable states there's going to be, but I'm just trying to help out here. All right, see what you think. I'm going to walk around and make sure everybody's feeling good. Actually, can we just to make sure everybody's starting off correctly, what is the starting state in the DFA? Remember, it consists of the original starting state together with anything you can reach by epsilons. Yeah?
I was just going to say the set of Q1 and Q4.
Yeah, you should start with Q1 and Q4 as your starting state in the DFA. I hope that you did. I gave you another hint just to make sure everybody is. I think that's an A going back there. I hope that's what you said. Feel free to talk to your friends. Okay. Yes, so this isn't, why is it, it's because, yeah, but I mean, why does this A go out here? It's because you can do, if you start yeah, you always have.
This also would come to.
I mean, yes, you could
Q4.
do A and stop here, or you could do A.
Oh, wait, oh, yeah.
Okay. Okay.
Yeah.
Oh, yeah.
So you want to think about if I remember Q1 or Q4, and I would be that's right. I think you could also make it
Oh, okay.
you always have to include these at times also. So it's here. What about Q3? No. Okay. Suggestion. Think of this as to this, so starting, so you can think, you can either here or here, but you can also do just here. You can also do think about that. You guys doing all right? There's too many states there. I'm not sure what, just for Q, I think actually this is not right. From here, Q5 should be in also. Because you can do four is about okay. So that changes over the rest of it. How's it going?
I have three right now, but I'm getting, I'm in an issue where I'm about to make another one.
This, I think, should be more Q1 or Q4.
So then this would be Q4.
Q1 is also.
Okay.
And you can also do this means
Alright, I got this surprise name with one more arrow here.
So then that's.
How's it going?
Q1, Q4,
Okay.
but if you look at Q1, let's look at Q1 evaluating. Let's say B. Let's say A first. Your options
Yeah,
are
so you need
look back to Q1
Yeah.
or look back.
You guys doing all right?
So Q1, Q4, right?
You should be a total
So
of
if you read B, your options are Q1, right? Q2, or
This.
empty.
So if you're in one.
You can't empty these because if you
Oh, right.
break Q1, and you read, if you were in Q1, you read the empty, or the B, or you can go here. If you just do this, you haven't actually read the B, you just read an empty string. So you can't end here, you need to go to 5.
Okay, so we take out this one.
Yeah, this is made the same, it is the same thing. You can't really stop it.
All right, let's talk about this. It's a little tricky, and it's very easy to miss something that totally ruins the rest of the picture, unfortunately. But Q1 and Q4, I put the loop back edge with an A. That's because from state Q1, you can do this A and end up in Q1 again, or you could also do this A followed by epsilon and end up in Q4. You got to remember the followed by epsilons make a difference. What about from here, the B arrow? Now, if you're in either of these two states and you do the B arrow, that can move you over to these two states. So Q2 and Q5 are reachable by doing a B, but there's also a B here. So Q1 can go back to Q1 by doing a B, and also Q1 can go to Q4 by doing B followed by epsilon. So the correct state to go to with a B here is Q1, Q2, Q4, Q5. That is very easy to mess it up if you miss any one of those little particular details. But from Q1 or Q4, you can reach any one of those 4 states by doing a B, including possibly B followed by epsilon. All right. I hope that that's clear to everybody. Very easy to overlook something when you're doing these. All right. Anyway, what about, okay, so this one is handled, right? The A, outgoing A and outgoing B. So from this one now, I have to somehow think about from any of these 4 states here, anything except Q3, where can I end up if I do a A? Well, I could start here and do A, so I can end up in Q1. I believe you cannot end up in Q2 by doing an A from any of those states. I can end here by doing A followed by epsilon, but I cannot end up here by doing A. So what did I just say? I think it's just Q1, Q4, or Q3, right? Because I can go across here. So Q1, Q4, Q3, that's the third state. Q1, Q3, Q4. It's like that. Anybody got questions about that? I hope that this is clear. It's very easy to mess it up, unfortunately. Okay. How about the B arrow from here? The B arrow. In 1, 2, 4, and 5, if I do B, the 1 can go back to itself. The 1 can go to a 2. The 1 can go to 4 by doing B followed by epsilon. And the 4 can go to 5 by doing this. I think this is just a loop back with a B. You can't make it to Q3, but anywhere else you can make it to. So this is a looped edge with a B. All right. And then the one on the bottom, 1, 3, and 4. From here, if I do A, I can end up in 1 again, or 4 by doing A followed by epsilon. I think you cannot end up in Q2. I think you also cannot end up in Q3, because even if you start here, you can't go, there's no loop back. You cannot end up in Q5. So what I say, I think just Q1 and Q4 are reachable from these 3 states by doing an A. That's like this. And then from those 3 states by doing a B, 1, 3, and 4, by doing a B, you can get to 1 again, you can get to 4 again, you can get to 2 like this, you can get to 5 like this, but you can't get to 3. I think that goes back like this. Like so. Those are all my arrows. I hope you got something like that eventually. Any questions about this one? One last thing is the accepting states. Anything including a Q3 or a Q5 should be accepted. That would be this one and also this one, because that has a Q3 in it and this has a Q5 in it. All right, this is our DFA. All right, this is how you do the subset construction. You'll have some more of these on the homework to practice with, and expect to see this on a test or something like that. All right, I think maybe we will end it at that. Next time we're going to talk about how do you know for sure these two are equivalent to one another. That's the whole point of this, is that the DFA language is the same as the NFA's language. We'll talk about that next time. All right, see you later. That's a few minutes early. If you want to hang around and talk about homework questions, I would be happy to discuss.